I mean,
And
do you want to?
yeah, that's good. So we are rolling, and my name is Bijan. This is Olshan. Say hello, Olshan.
Hey
Um,
guys, my name is Oluseun Taiwo.
yeah, so you were giving us, I would like you to give us some background on who you are and your experience and what you're up to.
Yeah, of course. So, my current role is an engineer on our advanced propulsion manufacturing team at Virgin Orbit. So that's really just a fancy way of saying we use 3D printing and hybrid technologies to produce the next generation of rockets and aerospace vehicles for Virgin Orbit, which is my company. I've held different in previous roles at other rocket companies, such as Rocket Lab, where I was in charge of additive production and effectively using powder bed technologies and DED technologies to, to increase humanity's reach in spaceflight and space exploration eventually. So, yeah.
That's really incredible. So, what's your like day in and day out like? What's like the big thing you're doing each day?
Yeah. So it's kind of weird, right? Because when you are utilizing newer technologies, right, that are used in crazy applications, I don't think the development cycle looks the same for each day. But I would say something that's close to it is get in and we're really trying to figure out how and what parts make sense to create via 3D printing, and if it does make sense, how can we, especially myself, how can I not only design for it, but communicate that to some of the design engineers as well too, and also, just basically how can I coach engineering teams in my company, not only on the propulsion side, right, but on the structure side as well too, and how to use this newer technology and get the most out of it, not only from a design aspect, but also from a weight savings weight savings opportunity as well too with cost, right? Because each time you're lowering the weight on the vehicle, you exponentially make the cost to orbit cheaper. So using additive not only for the process side, the automation side, right? Because it is a very high automation, low waste technology, right? But also then it's like we can make our vehicle effectively cheaper if we make big enough sections of this rocket using this process. So really just working with teams and coaching that, learning the technology myself, right? Implementing it, and with the ultimate goal of turning it over to production is really what it is, right? So it's saying we have a highly automated, successful process that we've communicated R&D with, and now we're turning it over to production teams to start scaling the crap out of it and make it faster and better each time we print and build. So that's what I do day in and day out. So
Okay, so let's see. What's your like personal like basically how'd you decide to follow this path? Like not a ton of people are um, even know 3D printing is as prevalent as it is, or that it has been scaled up for industrial purposes, but people just have no idea. So how did like you were basically in this like new kind of like a new market sort of. So basically, how'd you like first get into 3D printing and like just how'd you get started with that?
yeah. So I was, what was it? I was a sophomore in college, and to be honest, I sucked in engineering school, very
Mm,
much so. And I think there's a lot of engineers like me who love the application of engineering, hate having to go through the in my case, 4+ years to
right.
finish. And
Yeah.
yeah, and so so I actually was struggling. I had to take a summer class, and my parents were like, "Yeah, we're not paying for you to retake
Mhm,
calculus or whatever." And so
mhm.
I actually teamed up with a professor in the mechanical engineering department. He had a 3D printing lab, and effectively they had two types of technologies. One was DED, which is what we actually use to make really big parts now in a rocket at Virgin Orbit, and then we also had an SLS powder bed machine. And so I actually got to learn both processes in depth, help people write research papers on it. It was such a new topic at the time, but I saw the potential, right? So not many companies at the time were using the tech, but for some reason I could see like, wow, there's going to be such a need if we can hone this down, and not many people who know how to do this. And so there was a time where actually I just went all into additive, right? It's like school, school, additive lab. And that was like my life, learning, right? Different technologies, learning to design around it, learning material science, which used to be one of my biggest, I think, areas of yeah, of failure academically, which is now one of real funny enough, it's one of the biggest things that I do for the process internally at Virgin Orbit. So yeah, I get super psyched.
I really want to hear more about these research papers. So were these like academic papers that were published, or just like speak to that a bit?
So once again, I didn't write any myself, right? Because I wasn't a grad student, but I did help some people write theirs, and effectively, it was papers on what kind of technologies can we introduce to additive to be able to, instead of being reactive, right? Because so in manufacturing, you can be very reactive towards bad products and waste a bunch of time and money producing things that aren't great. But how can we make solutions, right, that are going to not be reactive, but are going to be proactive, right? So tell us immediately, right, something's not running nominally. DED, especially powder blown DED additive, is a very tricky, complex, process, right? And so it's like, how can we make the best products from that equipment? And if we can't, what do we need to introduce to do that? So there was a couple of projects that I worked on that I got to lead, which one of them was using effectively acoustic emissions, right, to calculate material flow to be able to get the best properties from that process. So that's just one to name a couple of some of the stuff that we worked on and that there's papers out there for. We've worked with NIST, we've worked with DMDI, we've done some stuff for when I was working at the lab to the Defense Department, excuse me. So lots of good research stuff out there on the work that we did. I think the only way that got me through college, the only way that I actually really got here was the opportunity to work in that lab, and then I got to go work at a national lab for like I think 9-10 months, right, to be an additive manufacturing guest researcher, and then I got to come to California and start my career. So massive effort to that lab and that professor. I'm going to say his name, Professor Shimarella, who believed in me at the time. Good mentors are the reason that you're anywhere, in my opinion. So,
yeah, it's definitely valuable to have someone there. And yeah, I had a similar experience with 4+ years of college, and I had a good mentor, Vika, from my the place that I used to tutor at. She was very supportive and encouraging. So I want to hear, I actually am not familiar with powder blown DD. Can you tell me more about that?
Yeah. So easiest way to think about it is you have this nozzle, right, that's blowing. So you have effectively the material that you're starting off with AM powders. With most AM material, that most metals, I should say, most metal AM, right, is spherical powders, maybe 50 to 120 microns round, in diameter, right? And so effectively with DED blown powder, what you're doing is you have a line, right, that feeds it from a material hopper to a substrate. And now at that substrate, you have a laser. It could be a 1 kilowatt laser, maybe more high power, depending on if you're producing, let's say, copper, for example, in this process. But effectively, the powder is meeting this high-powered laser on a substrate and fuses together and makes a solid. You can call it bead. I mean, we call them beads, whatever you want to call them, right? But effectively, it's this point where material comes and produces a melting effect, right? Where you have a bunch of these 50 to 120 micron powder particles that become one at the center, right? And then because of how fast the powder is being blown and you have control over that, you have control over the laser power and such like that, you can actually build really big things quickly. So for example, our competitor, Relativity Space, they are using a larger scale process than we are. Same process, but just larger scale. And they're building entire, rocket, like literally the entire part of the rocket, the fuel and everything, like the tanks. Like, so that's large scale stuff. When we're doing large scale stuff as well too, mainly in the propulsion realm, right? But that process allows my company and honestly not a lot of other companies, but my company and at least Relativity to make very big parts very quickly. And it's fairly repeatable. Once you have a honed in process, you can keep going and just keep making big things and then bigger things, then reiterate off of that to even bigger things. So it's kind of exciting. You can do things like combine materials that have never been combined before, which give you performance upgrades, which is awesome. So yeah, we do some pretty cool stuff.
So, how long have you been working at this place and in additive manufacturing in general?
Additive in general, or at the Virgin Orbit?
Well, like I want to hear both. How long have you been doing it at this
Okay,
place and then
so
overall?
I think 5, maybe close to 6 years in general, right? For additive. At Virgin Orbit, 2 years. At an aerospace company in Texas, about a year, and then at Rocket Lab, like 10 months. It's my first job out of school, and and the startup life was really tough. So my first inclination, right, was additive is cool, but in the startup space of space, I didn't enjoy my experience, but I kind of worked my way up into finding a company culture that not only fit for me, but that used technology in the way that I felt was made the most sense, and fit my talents the best. So.
Okay, so you've had 5 years plus, 6 years plus in the industry. Um, if to for anyone that might be interested in following a similar career path, what would be the most important thing for them to be focusing on, like in 2021? Let's say if they're graduating, they want to get into this market. What's the skill that there's not enough of, or that you personally think is most valuable or transferable?
Yeah, yeah. So I would say being someone who's open to learn, and then putting yourself in positions to get familiar with the technology, right? Because anyone can write an academic paper about anything, but very little people have hands-on time actually working on building this kind of technology. So also another thing I'll say too is additive is a very multidisciplinary um,
Mhm.
faction, right? So it's not just metallurgy, it's not just material science. You have metrology added into that. You have optics engineering, right? Like you have so many different disciplines that are converging, right? And obviously, no one's going to be an expert in all of them, right? But being able to learn and see how everything connects together, right? Physics, all that good stuff, right? Like seeing how like it's a beautiful, literally the moment you see one of these massive tools start printing rocket parts, it's crazy to see how many disciplines converge into one, and you're like, wow, cool that you have to know like a little bit of everything, and being willing to learn if you don't know stuff on that. So yeah.
Yeah, and so on that subject of like being able to learn on the job, and pick things up. Um, there's just I recently read a book, actually a couple books by Cal Newport. Have you heard of him at all?
Mm-mm.
Okay,
Okay.
so basically he talks about this idea of deep work and trying to um, really be able to in order to like learn new skills quickly, learn complicated skills quickly, um, you have to be able to like get away from distraction and really get deep into concentration, and avoid using like social media, and um, just being really limited and careful with your like digital consumption. Um, if you're performing at this high level, and I wonder if you have any here's an example of like some advice that Kel Newport gives from his book. He says that if you have he talks about this idea of schedule blocking. So you have a piece of paper and you put a line down the middle. On the left side, you have like your blocks, like 90-minute or 2-hour chunks, and you have like these groups of things you're supposed to be doing. And if things get you get interrupted, things get your plans change, then you use the second half of that page to try to make a new schedule and modify it. So that's like some technical advice that he gives. And he, by the way, he's a computer science professor at MIT, so he's this high performing academic guy. So I'm wondering if you have any technical advice for efficiency, productivity, avoiding distraction, and just kind of coping with technology, because it is a tool, but it is also something that has to be kind of uh, managed carefully. So any tips
Yeah.
on that?
Yeah. So I know for me personally, I can be very scatterbrained. I like focusing on multiple things at once, which means that the ball can be dropped. And so I needed, right, as a visual learner as well, I need to find a tool that helps me project plan, right? Because I'm being given 8 projects, right? And I might get all of them done, but there might be little details or micro projects in each one of those 8 projects that need to be done at scale and at speed. And so I really like to use a Gantt chart. A Gantt chart makes it easy for me to see when things start and when things end, and helps me kind of plan ahead. And I still am not perfect at always filling it in. It takes some diligence, right? So I think organization is a big one, not only for myself, but for a lot of people too. I also would say, I'm not going to argue with this MIT professor. Clearly leaps and bounds much further in his career and doing better probably than me. I will say, though, I think there's a balance. At least for me, what works for me, right, is there's a balance to everything, right? And as soon as I learn how to balance things, I don't have to completely shut things off in my life, right? So social media is a huge one, right? Because people think of it as this grand distraction. And yes, it can stop productivity and focus. But also people don't talk about, especially in tech, man, that actually having a platform, let's say like Instagram, right, can actually inspire the next generation of people that are coming up, finishing school, to kind of say like, hey, like this is what I could be working on. This is what the application of what I'm working on looks like. Wow, like I've never noticed, I never thought about that. I felt like for so much of me, like I didn't feel like I would have had a direction, right? Like on what I wanted to do with my career early on in college. And so anyway, I think social media can be used as a thing to inspire people as well too. But once again, like there's everything in doses of balance. I at least for me personally, and I know for some people that might work too. But I just want to be careful in saying that everyone has to cancel off certain things. I think you need to know what works for you, and then I think you need to know if you can do things in moderation, and if you can, great. And if not, yeah, then you need to remove it from your life. But yep.
Okay, so Gantt charts. Okay, so let's see. When did you get started by doing any like hobby printing, or did you just jump right into working in this lab?
Yeah, so actually, so working in this lab, right? So the SLS, it was like powder bed plastic, really was what it was. It mimics almost like direct metal laser sintering. But anyway, I had this industrial printer that, this is once again what I'm talking about, capitalizing an opportunity, right? No one else in this lab wanted to focus on this huge industrial piece of technology. All I had to do was ask my professor on if I can learn it and what we can make on it. And he was like, basically it's yours. So I got to manage that technology, the material. Like that's when I started to learn, right, what it takes in to genuinely run a machine tool, right, schedule all that, project plan for it, really be a student engineer, honestly, on it, right? And instead of hobby printing, anything I wanted to build, right, or learn the design rules for, I could learn it at work or at that lab, and it was amazing, right? It gave me a massive opportunity to learn design for AM before most people my age even knew what that was. So yeah, so I guess that would be considered my hobby printing, but getting to do it on an industrial scale was just incredible. So I got to work on some really cool projects. One of which I got to design a prosthetic for a girl who didn't have a right hand, and she wanted to play violin, and so I got to design a prosthetic, and that got me to being able to give a TED talk on it. So
wow, I did
awesome,
not know that.
massive stuff. Yeah, I can send you the link to it if you're interested.
Please do. Yeah, we'll link
yeah.
that in the description so everyone can check that out later.
Yeah, definitely.
Yeah, go on.
Yeah, no, I think just getting that opportunity actually set me up for where I'm at now, right? Like, so I could have done the traditional thing and then just, probably stayed in Illinois for X amount of years to wait to get a big opportunity. But there was an opportunity that was given to me because I had experience doing it at the university level, right? And knowing about a process that not many people my age wanted to learn. Like, I think once we flew to a conference in Ohio, and I was definitely the youngest one there. I wasn't even able to drink yet, and everyone was talking about design for AM and stuff. And I felt like I could contribute not as much, as some of these researchers and PhDs, but just a little bit of the knowledge that I had from being exposed and working in that lab. So definitely maximize opportunity is advice I would say.
Okay, so I had actually heard about that project from Jordan. Jordan told me about that prosthetic violin thing. I think you were also you weren't in the newspaper for that, were you?
Yeah, I was in national news for like a week. It was crazy.
Yeah, that's a really very wholesome project. Helping out this girl with this art thing, and that's very good. So Okay, so you did this TED talk. Was it a TED talk or TEDx? Is
TEDx
TEDx?
talk.
TEDx. Okay.
TEDx talk. Yep.
Yeah, very cool. So, um, you know, I had a couple of a friend of mine that mentioned um, trying to aspire to do something like that as well with these TED Talks. So, how did you get involved in that? Did someone reach out to
And
you, or did you reach out to them?
um, hmm. So my university had a TEDx talk, and I think at that point I was like, I'm. I've said this story like a bajillion times. I don't know if I want to say it one more time. I sometimes get really nervous about public speaking, but I think it was like the dean had sent me like like an email like as a student. He's like, yeah, you're gonna apply to yeah.
He
He's like, you're
told
gonna
you.
apply to do this talk, and I'm
Okay.
like, okay. And so I go to the audition, and people have things like written out or whatever, which was really cool. That people were passionate about their stuff, and I was just there as like, you know what? I don't need to come. I don't want to come scripted, right? I want to tell people a story that changed my life and changed somebody else's life using a technology that people limit very much so. And so I think the things that had gone for me in that sense was the fact, yeah, like I said, like, you know, technology that not a lot of people had thought could change lives just yet, right? 3D printing, even now in 2021, I feel for most companies is still a buzzword. Actual there's not actual life-changing leaps and bounds forward in it. But I kind of could see that, and I based my talk off of real emotions, right, felt on my end, but also the person, you know, the woman that I was helping at that time, you know, make a prosthetic for her. I felt like there was a story that needed to be told, and how, you know, when we use technology responsibly and correctly, right, beautiful things happen. And so that, you know, I thought that was a pretty cool thing. So, yep.
Mhm. Yeah, I think a lot of people are interested in. I mean, I'm personally interested in 3D printing, and like I just sent you earlier today. I sent you this picture of my phone case that I got printed earlier,
Yeah, it's pretty cool.
and I think it turned out
Yeah.
pretty good. But so people that might want to be interested in this, I mean, if you're interested in it as a hobby, I think there are some pretty decent printers you can get for under $1,000, even around like the $500 mark. You can get some decent hobby printers. Would you agree with that figure, by the way?
Yeah, I would say, especially if you're a beginner hobbyist, yeah, definitely below,
Yeah.
you know, 500 or below, you can get something good.
Yeah, I think so. I think as a hobby, there's like a lot of people are interested in that, and then for working in the field as like a professional like you though, um, is there is it like it's probably mostly required that they have the 4-year engineering degree. Are there any like adjacent is there any work that can be done in that area that can
Yeah,
only be done with an associate's or like high school or lower
yeah,
than that for people? Because some people might be interested in that.
yeah, totally. I would say that actually, yeah, I would say the 4-year degree helps if you want to strictly be in an engineering role. I know that there's some exceptions for people as well too, like people that have a lot of experience, let's say in actually fabrication and producing, and there's sometimes some companies might forego that. I would also say for additive too, it's not yet like most fields where it's like, oh, you have this 4-year requirement, because there's not a lot of people that actually have hands-on time producing hardware, right? Whether it's space or automotive or whatever. And so I think, yeah, so I think there's space for everyone. And then I think also too, there's like technician roles. Yeah, there's so many different, like, I don't think, it depends what you're trying to do there, but I think in that space, there's opportunity pretty much for anyone who wants to learn still. That's why I push anyone who has the opportunity to be around, you know, heavy machinery, like we're working with and whatnot. I would say if that's something that interests you, please continue in that, because you will be part of a list that's still fairly small of people who have a skill set that's going to be needed over the next 5 years, 10 years, 20 years, right? I mean, people are talking about printing on the moon to make habitats, you know. So I think, yeah, I don't think this technology is going away anytime soon, but I think the number of people that are needed to make it happen, I think will continue to steadily increase. So,
Okay, I think this was a really good conversation, and I'd like to have you on again in the future. So, all right, take care.
take care.
Thank you.